Use the derivative formula. F prime of a equals the limit as x goes to a of f of x minus f of a over x minus a. To find the derivative of f of x equals the square root of x squared plus 5x, where a is going to be a 4. First thing to do here is to write the derivative formula for the a value of 4. That will be f prime of 4 equals the limit as x goes to 4 of f of x minus f of 4 over x minus 4. The next thing to do is put in f of x, square root of x squared plus 5x, minus f of 4, which means to plug a 4 into the f of x, 4 squared plus 5 times 4 under the square root. And that entire thing is over x minus 4. We have the 0 over 0 indeterminate form, and we will continue to have that until we can factor the numerator to get an x minus 4 factor that will cancel with the x minus 4 factor in the denominator. So that's our goal here. I have a root involving x in some way, and it's added or subtracted with at least one other term. That second root is going to be a number of some sort. And so we have a root combination in the numerator, and it sounds like we're going to want to make use of a root conjugate. Before we actually formulate the root conjugate, let's simplify that second root. Let's get the number there. It just will make our work a lot easier. So f prime of 4 will equal limit as x goes to 4 of the square root of x squared plus 5x, I'm not going to do anything with for now, minus the square root of 4 squared, which is 16, plus 5 times 4, which is 20, all over x minus 4. And this would give us then limit as x goes to 4 of the square root of x squared plus 5x minus the square root of 36 all over x minus 4. So we will have the limit as x goes to 4 of the square root of x squared plus 5x minus the square root of 36 is a 6 over x minus 4. So we still have the 0 over 0 indeterminate form. We haven't done anything to change that just yet, but we have a root combination in the numerator, and we can therefore multiply the numerator and denominator by a root conjugate. So that we can attempt to remove the 0 over 0 indeterminate form. Now we're going to put the root conjugate over itself so that we have a form of 1. And as always with a root conjugate, we're going to only FOIL out the conjugate pairs. That's in the numerator. First, root of x squared plus 5x times the root of x squared plus 5x will be x squared plus 5x. Outside, the root times a positive 6 will be a positive 6 times the root of x squared plus 5x. Inside, a negative 6 times the root will be a negative 6 times the root of x squared plus 5x. And then last, negative 6 times a positive 6 will be a negative 36. Now the outside and inside terms will be equal value and opposite signs, so we'll be able to cancel those out. You don't even have to write them if you don't want, but I do just for the completeness, and I just cancel them out so that you can see what happens to them. In the denominator, we're not going to FOIL out, since those are not root conjugates of each other, but keep them multiplied in a factored form. So what we have left is limit as x goes to 4 of x squared plus 5x minus 36 all over x minus 4 times the square root of x squared plus 5x plus 6. We haven't changed the 0 over 0 indeterminate form just yet. If you plug a 4 in the numerator, you are ending up with a 0, and then in the denominator because of the x minus 4. But the numerator is factorable. It's a trinomial quadratic. And so our next step is to factor that. Because it's 0 over 0, I expect an x minus 4 factor in the numerator as well. It's x squared, so it'll factor to an x and an x. I need two numbers that multiply to be a negative 36, so one will need to be positive, one will need to be negative. And then add to a positive 5. Well, 36 can be 36 and 1. That will not give us a 5. It can be an 18 and a 2. That won't be able to give us a 5. It can be a 12 and a 3. That can't give us a 5. It can be a 4 and a 9. That sounds good. Because we want a positive 5, it sounds like maybe a positive 9 and a negative 4 will take care of that. And there's our x minus 4 in the numerator. That we'll be able to cancel with the x minus 4 in the denominator. And once we do that, we no longer have the 0 over 0 indeterminate form. So let's cancel those out, because that means we can now plug in a 4 for each of the remaining x's. X plus 9 divided by the square root. I'm just rewriting what we have left after canceling those. But let's go ahead and plug a 4 in for the remaining x's. So we'll have 4 plus 9 over the square root of 4 squared plus 5 times 4, and then plus 6. So in the numerator, this will give us 4 plus 9, which is going to be a 13. In the denominator, we will have the square root of 4 squared, that's a 16, plus 5 times 4, that's a 20. And then we'll have that plus 6. So we have 13 divided by the square root of 36 plus 6. 13 divided by 6 plus 6, or 13 over 12. This represents f prime of 4. F prime of 4 means the derivative of f of x, and then evaluated and an x value of 4.